Good evening, and welcome to Kopernik Observatory. Great to see you all here this morning. This evening. I had my COVID shot yesterday, and I'm still recovering from it. So, a bunch of faces are familiar to me, but a couple of the new faces for me. For the new faces, have you been here before? Yeah. All right. Great. I also want to welcome those people watching on the live stream. Again, I've got here up on the screen our website, which is where you can always find what's going on. Right now, we're at our sort of year-end fundraising campaign, and you can learn more about that by clicking here, reading the campaign letter. But always we indicate what's next up on the schedule. So tonight's program is Science and Religion. But again, if you go to the website, you can go to Classes, Events, and Programs, and then down to Public Programs, and you click there, and you see what's coming up next. So tonight is the talk on Science and Religion and Climate Change. For the next 2 weeks, then, we are going to have a viewing of a movie called The Star of Bethlehem Revealed. And that, unfortunately, because of copyright laws, we can't live stream it. So that'll be an in-person event only. And then next Saturday, if the skies permit, we will be open for the Geminid Meteor Shower. And we'll just invite you to come up for that and make sure you dress warm for that. But then in January and February, we sort of just peel back to just one program a month. Our winter skies will be at the end of the month. Come up and learn what you can see in the winter in the night sky. And then always in February, right around Kopernik's birthday, which actually is February 19th, but on that Saturday, February 21st this year, we'll be celebrating Kopernik's 553rd birthday with a number of family activities, speakers, and of course, if it's clear, we'll invite you to look out at the night sky. I mentioned earlier that we've got the live stream here, and so this is our YouTube channel, and this is where you can find the upcoming programs and when they're scheduled for, but also you can go back and see what we've done in the past. Last weekend we had Black Holes on Black Friday. We've talked about a meteorologist from the National Weather Service was up talking about a summer review and a winter preview. We had to talk about the mysteries of Easter Island. So it's not always about astronomy. It's really the kind of thing that I really enjoy is expanding my knowledge of how the world and how the universe works. So for those of you, we're saying that this tonight's program is actually part 3 in the series. About a year ago, Dr. O'Brien did his first pass on this, and about a year ago, and then back in March, he did the second in the series. So if you want to catch up the other two, you just go back in the look back into the archives here, and you will find those talks. As I mentioned, we're now at a point where we're sort of on the home stretch of our year-end campaign, and again, if you like this kind of place, your support is really critical to keeping the doors open. So, in whatever way you can support us, we really would appreciate that. And another way to support us also is becoming a member. We belong to what's called the ASTC, Association of Science and Technology Centers. And our Kopernik membership gets you into over 380 other science centers. The ASTC now is requiring that, like for a family membership, that the minimum cost for that has to be $100. So we're having to raise our price. So what we're trying to do is make people aware of that, so that if you either renew your membership or buy get a membership prior to January 1st of next year, you can get it at the current pricing. So it's $100 for the family membership. I think it's $40 for an individual membership. And so if you like this kind of place and you'd like to support us, please consider becoming a member. All right. So I said we're very fortunate to have some great resources in the area that come up here and talk about their particular area of expertise or interest. And Dr. Tom O'Brien, who actually is a board member of Kopernik, has offered to do these programs on science and religion. And so I think I'm going to just pass it right over to you, Tom.
One, two, three. All right, great. Well, thanks. Whoa, thanks for coming out tonight on this chilly night. And for those who are online with us synchronous, thanks for joining us. And for those who in the future will catch us asynchronous on YouTube. One of the neat things Drew mentioned about the Friday Night Live programs is that you can go back and catch any of them. And many of you probably are aware of, with your YouTube, you can do it at double speed, 1.75, 1.5, 1.25, or 0.5. So you can speed up, and of course you can stop and take screenshots. So all those resources are available. So as Drew mentioned, this is the third talk in this series. Tonight we're going to be looking at a couple streams. Stream one, sort of a little bit of the history of the science of climate change. Many people think it's new. The key elements of this were known at the time of the American Revolution. So not new. Secondly, the religious perspective on stewardship and the notion of consilience between those religious perspectives and the scientific perspectives. There's an opportunity for synergy. Synergy, in simple phrase, is when 1 + 1 = 10. The phrase, the whole is greater than the sum of the parts. And the whole universe, as we know it from a physical point of view, from a scientific point of view, is based on synergy. Systems within systems that do bigger things. So that's where we're going. Take-home message, sort of begin with the end in mind. This is a season as a Christian of hope and peace. And the world desperately needs that. I'm going to have a lot of resources on the slides. If you're interested in YouTube talks and things that are powerful, catch it. It'll be posted within a few days or something, Drew?
This?
Yeah.
Later tonight.
So you can go back and play these. A really, really interesting book by a top climatologist, Catherine Hayhoe, Saving Us, a climate scientist's case for hope and healing in a divided world. We're coming off of, we had a transition from COVID with an outrageous number of needless deaths. Then we had the attack on the Capitol. And since then, we've had all kinds of chaos. And so it's real easy to give in to despair. And as a Christian, that is the antithesis of what Christianity is about. Christianity is a religion of hope and belief in healing and transformation. And the notion that we can take something bad and not just make it better, but make it better than before. And that actually is the progressive nature of science. Couple quick things related to the previous talks. Talk number one, the first idea I want to get out of there, it's important, is the concept of consilience. Consilience is a term that when you have different areas of research in or out of science that are all pointing to the same conclusion. And that's fundamentally the way science works. We have all kinds of different disciplines, but those are, as I would tell my students, are useful fictions. All knowledge, as the Greeks believed, is integrated. And the two words that have both biblical references in the Old and New Testament and scientific is logos, the word, which I was explaining to our mathematician here. Many people would argue the word of the universe is math. And Galileo basically said that. And cosmos, or order. Seemingly otherwise, everything seems diverse and chaos. But in fact, the logos and cosmos shows us the underlying order of the universe. And from both a Greek and a Christian perspective, the good, the true, and the beautiful. So the first talk looked at the overlap between the history of science and religion. Second talk focused in particularly on the controversy, which is more made up than real, around evolutionary science, that somehow it's anti-religion. It's not. What is useful, both fields of science and religion have something to say about our dual nature, how we can be selfish and ego-driven, and how we can be selfless and other-driven. And the best happens in science and the best happens in society when people work together to build new, better things. So that was the second talk. The third talk today, I've got to take one idea from it. It's a phrase and it's a picture. The picture of Spaceship Earth. That picture, which the Apollo program gave us, 1968, was that a year before we landed on the moon? 69, I think, landed on the moon. So we had this image. That image, the notion of, whether you say the religious, the brotherhood of man, or the sisterhood of man, we're all connected. We're biologically all one species. And in fact, we're related to all the other species. Much of your biochemistry is in the simplest bacteria that lives on the planet. We are all connected is a fundamental principle of science. It's also sort of a philosophical and poetic. Walt Whitman, the famous American poet, talked about the divine ship of Earth. All peoples in the globe together sail the same voyage, are bound to the same destination. George Orwell of 1984 fame, and sometimes in 2025, there's certain correlations between both Animal Farm, which he wrote, and 1984, said the world is a raft sailing through space with potentially plenty of provisions for everybody. The idea that we must all cooperate and see to it that everyone does his or her fair share of the work and gets his or her fair share of the provisions. I love this. Seems so blatantly obvious that one would say that no one could possibly fail to accept it unless he had some corrupt motive for clinging to the present system. That is both scientifically true and spiritually, religiously true. So take home, if nothing else, Spaceship Earth, that picture, we're on the same planet. And curiously, the phrase economics, eco means home, ecology means home. We need to start using the math, as I was talking with you before, to make the planet work better, to make society work. Okay, religion. Book of Genesis. There is one portion that is misinterpreted because of translation errors. The English, we commonly say, be fruitful and multiply and fill the earth and subdue it and have dominion over every living creature. That actually, those words are not what the original Hebrew and later Greek. Most of our writings from the Bible actually were translated in Greek. They have much more to do with cultivating and taking care of, because the whole Old Testament and New Testament perspective is that we are guardians, stewards of a garden we don't own. We've been placed here to take care of it. And metaphorically, one might say that the fall of Adam and Eve was really about it's I, me, mine. I want, regardless of what the greater needs are. So we had, in the biblical myth, if you will, the Garden of Eden, we had everybody, even animals, carnivores and herbivores, were cooperating. We had this peaceful, and we blew it. We have another powerful story from the Bible, Noah, where we just restarted. And we restarted by bringing two of every kind. They didn't know that there's asexual creatures, but they brought two of every kind of the sexual creatures. But this concept from the Bible that we have a responsibility to care for our planet is very much built into the Bible as well as science. So there it is again, one more look at Spaceship Earth. This is post-landing on the moon. And this is probably the best known phrase. Adlai Stevenson was a twice failed Democrat runner for president. He had the misfortune of running against Ike, President Eisenhower, twice, and lost both times. But he said, we traveled together passengers on this little spaceship, dependent on its valuable reserves, all committed to our safety for its security and peace, preserved from annihilation only by the care, the work, and I will say the love we give our fragile craft. No craft, no crew can travel safely with such vast contradictions. On their resolution depends the survival of all. That is a principle any religion, Buddhist, Christian, Jewish, whatever, would absolutely agree with that statement. And it is also a statement of science. We all are on the same planet. And as we'll learn deeper as we go into the chemistry, there's no boundaries of air and water. We draw these lines in this globe. You don't see all the you don't see Russia, you don't see China, you don't see USA, America first. That's us. That's our common home. So that's a major message from science. These books were instrumental in my own development. As a middle school student and high school student, I got very interested in the environment. So I got a degree in chemistry and ecology and also was certified to teach. I should say, disclaimer, science is awesome. From the Christian perspective, our God is an awesome God, is the phrase. Those two phrases are not contradictory. I've been in Catholic schools. I've been in public schools. I've taught in Catholic schools. I've taught in public schools. I just finished 38 years as a professor of science ed at Binghamton University. I have never seen a conflict in my life. And the synergy between the two is very interesting to me. So these couple of books were really instrumental in I read them in the early 70s, Operating Manual for Spaceship Earth. So thinking about systems. Religious and scientific contrast. Martin Luther King, clearly a Christian minister, said we're caught in an inescapable network of mutuality, tied in a single garment of destiny. Whatever affects one directly affects all indirectly. This is the interrelated structure of reality. That is a scientific statement. As a chemist, that's the way the world works. John Muir, I just got back from a week of hiking in the Smokies. Just amazing. Amazing nature. John Muir, who was an interdisciplinary scientist, geologist, ecologist, said when we try to pick out anything by itself, we find it hitched to everything else in the universe. So again, take-home message, I'll keep repeating, Spaceship Earth. We're all one planet. We're all related. We need to care about each other. Martin Luther King, we just take the quote on the right. Our scientific power has outrun our spiritual power. We have guided missiles and misguided men. If he was alive today, we'd say we have artificial intelligence and stupid human beings. The wars and other things we're doing are completely ridiculous and counterproductive. The question then is, what's the role of rational inquiry or logos in religion, and what's the role of ethics and values in science? And so what we're going to do is just a little walk through some history of climatology to show you that these interconnections between science and religion have always been there. Lavoisier, the French say he's the father of modern chemistry, did his research at the time of the American Revolution. His research helped support the American Revolution. We had next to no gunpowder when the war started. If the French hadn't given us gunpowder, the war would have been over in a week. So we got massive shipments of gunpowder from the French. But it turns out it was better gunpowder than we and the British had, because he was working on making better fertilizers, and the same chemicals used for fertilizers are used for gunpowder. And so we improved gunpowder and fertilizers at the same time. A devout Catholic, unfortunately, French Revolution, unlike the American Revolution, took a different turn, and they chopped his head off. But the main thing that he had to say, his main claim to fame, was the law of conservation of matter. And he said, basically, anytime you do a chemical reaction, so over here, I've got some carbon atoms, coal, and some diatomic oxygen, the air we breathe. Over here, oops, lost one. Can we find him there? Under your, right over there. Math guy, pick up the red one there? Great, thanks. Drop him back in. On this side here, when you burn pure coal, which we haven't had good coal since anthracite coal got mined, clean coal, which is not clean, but it's way cleaner than what we've been burning the last 50 years. Anthracite got all mined out a long time ago, but you get only carbon dioxide. And it turns out when you burn coal, if you count every atom, you have the same number on both sides. So every chemical reaction you do, if you include any gases, it weighs the same before and afterwards, because it's just a rearrangement of atoms. Think of it, if we were dancing, and I was dancing with you, and you were dancing with you, and you were dancing with her, and then we, okay, find new partners, and we shifted partners, we'd all weigh the same. Every chemical and physical change you've ever seen, that's the way it works. So, all of you have probably played with the kids at some point, taking baking soda and throwing vinegar in. And if you put a balloon on it, it blows up. That's sort of cool. What most people don't do is weigh it. And if you weigh it before, so this is just a sample you could take, whatever amounts. In this particular sample, the baking soda and vinegar weighed just under 4 grams. And afterwards, you form salt, water, and carbon dioxide. It weighs the exact same thing. That was figured out at the time of the American Revolution. Think of the image of Spaceship Earth. That's Spaceship Earth. We lose a little bit of hydrogen and helium that escape the atmosphere. We gain a little meteorites. But as a percentage, it wipes out. Planet Earth weighs the same now as it did 50 years ago, as it did 1,000 years ago. Inconsequential mass shift, because the atoms all stay the same. So chemistry is a science of counting atoms. You just count atoms before and afterwards. And the whole Earth is basically a constant mass. Joseph Priestley. Those of you local here probably know there's a Unitarian church down by Guthrie Lord's Hospital. The co-founder of that was one of the 3 top chemists in the world at the time of the American Revolution. He was also a theologian. He was the co-founder of the Unitarian faith, which some people say isn't quite Christian because they're very egalitarian and they let 1,000 flowers bloom. But in any case, he actually was the chemist who figured out the basis of what we now call the field of ecology. And he also was a personal friend of Ben Franklin and a protege of Ben Franklin, who wrote up much of the research Ben Franklin did on electricity. He was a good friend of Thomas Jefferson. Motivated Tom Jefferson wrote his own Bible. People that claim, oh, our founding fathers. Thomas Jefferson was criticized for not being Christian. Thomas Jefferson believed Christ was the most benign, most brilliant human being that ever lived on the planet. His Bible threw out the whole Old Testament, took the New Testament and threw out every miracle. Over about 35 years, he wrote his own Bible using 5 different languages, translations. Traditionally, that wouldn't be called Christian. One of our key founding fathers. He was deeply religious, though, and a good friend of Joseph Priestley. So what did Joseph Priestley figure out? Simple experiment here. He actually did much more. If you take a mouse and you put it in a bell jar, the mouse dies, even if you have food there. If you put a candle in a bell jar, the candle goes out. If you put the 2 of them together, the candle goes out and the mouse dies quicker. If instead you put a plant in with them, the candle stays lit and the mouse stays alive. That is the science of ecology. Basically what he figured out is that whatever a candle and a mouse need, and it turns out we need the same thing, and we call it oxygen to burn, and your body is burning. It's called cellular respiration. Every cell in your body takes a fuel, let's say sugar, and burns it with oxygen to produce carbon dioxide and water, and builds up the rest of your body in the process. But what he figured out is that these 2 things, and we'll just take the plant and the animal, make it simple, that they're complementary and in balance. He was concerned and wrote to Ben Franklin. I should say they burned his lab. The best lab in the world was burned to the ground in England because in addition to being a radical Christian, he was pro-America. Not a good thing to be in Britain. So they burned the best lab in the world to the ground, and he came to live in Pennsylvania. The highest award that an American can get as an American is called the Priestley Award, the highest chemistry award. The Nobel Prize, which we'll talk about later, we have one on campus, that is an international prize. But in any case, so what he figured out is Spaceship Earth is essentially a closed container. And at that time, we were burning lots of trees, taking away the plants that were recycling what the animals put out. So Lavoisier and research over the next 200 plus years figured out this famous equation. If we have 6 molecules of carbon dioxide, 6 molecules of water, we have photosynthesis, and this is not a simple process. We get glucose and oxygen. That makes all the food on the planet. And then animals eat plants as well. And then animals eat animals. It turns out the reverse of it, and again, this is the beauty of the balance. Every chemical reaction on the planet theoretically can be run in reverse. And when it's run in reverse, you get the exact same atoms in the exact same numbers. And it turns out if it takes energy, in this case going to the right, Photosynthesis pumps in solar energy from 98 million miles away, is stored in plants. When plants are either burned or eaten, the exact same amount of energy is released. These basic ideas go back hundreds of years. This is the basics of climate change. This is way more complicated than we need. It's simply to show that our use of carbon on the planet and oxygen are in balance. And the interesting thing here is the dark stuff. So what happened hundreds of millions of years ago? We had excess CO2 compared to today, excess CO2 in our atmosphere. And we grew massive sized plants. If you've seen, not just animals, but massive sized plants, ferns the size of trees. It turns out they were buried, and due to the particular geological processes at the time, over hundreds of millions of years, we can think of that energy as stored sunshine. And we pulled carbon out of the air, and we buried it deep underground. Since the time of the American Revolution, the Industrial Revolution, we have been releasing over 200 years what was buried over hundreds of millions of years. So this natural balance that exists on the planet, we've skewed in the direction of putting out a whole lot more carbon dioxide. We'll show you more, how much more in just a minute here. Let's do that now. So here I have, this is the basic unit of volume in the metric system. You may remember from school, you think of the liter. Well, the liter is this little size here, approximately a quart. A little bit different, but approximately a quart. So a liter is a cubic decimeter, 10 centimeters by 10 centimeters by 10 centimeters. This here, inside here, if we picked one of these little guys, this is a cubic centimeter. I could have 1,000 this way, 1,000 that way, and 1,000 up. That's a million. So if you get water bills, if you own a house, the purity of your water is, ingredients are listed in parts per million of pollutants or essential nutrients that are in the water. That is 1 part per million. This here is how much CO2 was in the environment at the time Priestley was working. And it turns out, as far as we can record, back through trees and ice cores, this has been the constant amount of CO2 in the environment since, at least 400,000 or 500,000 years, way longer than humans have been here. We'll look in a minute what humans have done. Comments or questions about that? I'm talking really quick, yeah.
Okay, so is it the whole cube that you're holding is the amount of CO2, or is the orange?
The orange things. Yeah, and we'll show you how much in just a minute. Yeah, yeah. Anything else? Okay. I have 3 slides here that have lots of details we don't need. But again, for anyone interested later, and particularly if there's any teachers looking at this on YouTube, there's a lot of really neat chemistry here. The only thing I want to point out is that about the time that the first oil well was drilled just down the road in Pennsylvania. So our whole oil industry started in our country in Pennsylvania. If I can get the bag across here. About that time, 1859, so Walt Whitman was writing his Leaves of Grass, which he kept revising over like 50 years. An Irish chemist figured out this molecule, CO2, so the black represents carbon, the red represents oxygen. Atoms aren't colored. They're way too small to reflect visible light, so you can never see atoms. So they're way too small. So they're not colored, but it's a nice way of following it. What he found out is that this molecule was really efficient at trapping what we call heat or infrared energy. It can rotate, it can translate, it can move, but the other thing which this model doesn't show well, I'll try to do it a little bit, it can, on one side, it has like a spring in it. It can do this. Think of a swing that you can push that absorbed energy, and you can get them higher and higher. This absorbs infrared, and that was figured out back in 1859 when Walt Whitman was writing his Leaves of Grass. So again, not a new idea. Lots of other things, but the main thing is this notion that CO2 in particular and water to some extent absorb infrared, which we call heat from the sun. Lots of research happened from the 1930s to the 1960s. The only thing I want to point out is that Joseph Priestley actually invented carbonated water, soft drink, and it was marketed free as a health drink. We didn't put truckloads of sugar in it. It's a deadly drink now. Soft drinks are deadly. Highly recommend if you drink them, and it doesn't matter, diet or regular, that you stop. But in any case, he figured that out in 1767. 1970s, we figured out that the oceans were getting more acidic, that all this excess CO2 that we produce every time we burn a fossil fuel, the cleanest fossil fuel, you get this. All that excess stuff was a lot being absorbed in the oceans, and they were acidifying the oceans, which was killing species and bleaching the coral, which is, the oceans are one of the most diverse life ecosystems on the planet, and we're killing the oceans. And that's been known since the 70s. Another big idea, tragedy of the commons, relates to the biblical story of Adam and Eve. So if everything is in common, everybody that only cares about themselves, you'd grab the most of whatever you can, regardless of any rules. It turns out the air and water are common to the planet. So if there's no tax for using it or polluting it, you get as much as you can and you pollute as much as you want. It's called the tragedy of the commons, and that's a major problem. And so by the 70s, we decided, both we, United States, and the world decided that we needed to start preserving the planet. So we had some laws, oops. In particular, President Nixon, known for many things, but a well-known Republican president, started the Environmental Protection Agency. About 18 years later, UN started an intergovernmental panel on climate change. So by 1988, I started working at BU in 87. By 88, we knew that we had a problem with climate change. Again, this is not something new. It's well established. I mean, we have it because about 83% of the energy we use in this country comes from burning coal, oil, or natural gas. And the cleanest of those produces CO2. In the case of natural gas that some of your homes may be heated in, every molecule that burns produces carbon dioxide and water vapor. And the CO2 can cause problems. And here's the problem. So at the time of the American Revolution, we had about this much. So if this was air, we had that chart. If this was air, a cubic meter of air, this is how much CO2 we had in here. This is 280 of these little cubes, the smallest ones. And it turns out we have research that shows that had been constant for hundreds of thousands of years. So human beings adapted to how much oxygen was in the air, how much carbon dioxide was in the air. Our whole evolution was tied to that. This is where we are now. So I picked a different color, just black. This is how much has been added. Since Joseph Priestley and our founding fathers was working, that's over a 50% increase. That's not sustainable. And you might say, well, in the whole volume here, that's not all that much. This disproportionately, this carbon dioxide in the air causes truckloads of problems. So increased hurricanes, increased lightning storms, increased flooding, increased drought, the whole mix of things. So we have global computer models that explain that. So that's what we've been doing. Again, more details than we know. Think of a blanket. The greenhouse effect is a good thing. If you're a planet or a moon that doesn't have an atmosphere, your temperatures swing widely. So An atmosphere provides a blanket, and it's ideally sort of a one-way blanket. You let some things in, not other things in, and you let some things out, not other things out. And again, over hundreds of thousands of years, that constant amount of CO2 that was in the environment had this nice amount, this balance. When we added, we increased, and I'll say particularly the CO2, but also methane and dinitrogen oxide, we made this blanket less permeable to letting heat out. So we're overheating the planet. If you were in your bed, some of you may use these weighted blankets. One of the downsides is like you get super hot because all that heat's coming from your body. So the heat that the planet would naturally lose, that it should lose, it's not losing. So we're warming up the whole planet that way. Again, lots of science. There's only two things I want you to get here. One is, can you help me, Elaine? And can you help me too? So you all know a thermometer. This is a fancy thermometer. They're called love meters, and we're not going to do anything fancy with it. But if you'll stand up with me. So I want you to rub your hands together, if you will. What do you feel?
Friction.
Friction, and how else do you experience that besides friction?
Heat.
Heat. Hold the bottom of that bulb, and so everybody can see. Hold it up so people can see. This is basically a thermometer with a liquid that expands more quickly. Just do the same thing, if you will. And then hold just the bottom. And maybe walk it back even and let the people in the back see. And you can do the same thing, let it cool off and walk it back. So what we're doing, if the planet's heating up, the liquid on the planet is heating up. And when any liquid, whether it's alcohol in a thermometer or water, when you heat any liquid, it expands. Because the molecules are dancing and there's spaces between them, when you heat it up, they dance further apart. So that principle is why we have coastal flooding. Now, there's two things that are going on that cause coastal flooding. One is simple thermal expansion of water. If you heat any substance, but particularly liquids, they expand and they take up more volume. The second thing that's going on is that the heat is causing ice to melt. A simple experiment to do at home, put ice in a glass of water, mark, tape, or whatever the level, and then the question is, when the ice melts, what happens to the water level? Any thoughts on that? So you got a glass with water in, you got ice cubes in, you tape where the water level is. Half an hour later, you come back, the ice is melted. Where's the water level? Well, it can be up, it can be down, or it can be the same. Those are the three choices. Any guesses? Have to do it at home. What's your guess? Up. No. It turns out icebergs melting in the ocean don't raise the water level at all. What does raise the water level, if you're Iceland or your Greenland or your glaciers anywhere, and glaciers, like if you want to see our glaciers, I just got back from the Smokies. If you want to see the glaciers, you really should do it probably in the next 10 years because they're going away rapidly on the whole world. And it turns out if ice is on land and it melts and it goes into the water level rises. And you can do that at home if you just have a cork on your glass of water, no other ice in it, put an ice cube on the cork. And when you measure when the ice melts, and again, that's pretty obvious, even visualizing that, if you have a cork floating in a glass of water and an ice cube on top of it, when the ice melts, the water level rises. So two reasons why we have flooding. There is a third reason. The third reason, we're putting more water up into the air, and what goes up must come down. So lots of other science there for chemists that want to look at this online. But those points about why do we have more water flooding, and then the second point is it takes energy to melt ice. It takes energy to take liquid water and make it steam. The exact same amount of energy is released when it comes back. This amount of energy here is huge. So the water that we put up in the atmosphere, when it condenses, it releases energy. And we hear that as thunder and lightning, and we cause excess energy to go out that causes hurricanes, tornadoes, etc. So a couple points of science there that are worth knowing. It turns out the Exxon and other companies knew this. A recent report called Decades of Deceit by Union of Concerned Scientists has detailed the fact that just like with the smoking industry, Exxon and the other companies knew that we had this crisis. And they were talking about it as far back as I was born in 56 and 59. There were scientists already telling Exxon, we've got a problem here. By 68, they said by 2000, we're going to be screwed. And in 78, around the same time that the chemist who's now a Nobel Prize winning chemist at BU, wonderful man, Dr. Stanley Whittingham, worked for Exxon and invented the lithium-ion battery. They weren't interested. Another point of reference, in 79, I was teaching high school science. President Carter put solar panels. These were simple thermal panels. They weren't photoelectric panels, so they heated water. Put them at taxpayers' expense on the White House. They would have lasted for decades. When Reagan came into office, within a few years, he took them off. And what's more important as a teacher, and I wish I'd kept the original information, but there was a, under President Carter, there was massive energy education materials, and it was some of the best stuff I've ever seen because it integrated economics, other social sciences, mathematics, history, and science. Free, and I was using all this stuff. Right after President Reagan took office, the very last of the materials was produced, and I wrote to Department, no internet, wrote to the Department of Energy for that material, and I got a letter back. You need to understand, with the change of administration, there is no longer an energy crisis. Therefore, there is no need for energy education materials. These materials are being warehoused to be burned without energy capture. Therefore, I cannot send you these materials. And he sent me the materials. So none of this is new. That's, again, I started teaching full-time in 78. So we've known all this stuff. There's been great materials, and we've ignored it, largely. If you get your energy from NICEC, NICEC is owned by a Spanish company. So this is the industry saying. So Iberdrola, if it's pronounced that way? Iberdrola. In any case, NICEC, by another word here, has a report out that says the cost of adapting to coastal flooding, people are going to lose capacity to work due to heat that's happening already in our country, more wars to gain access to limited resources, fresh water is going to be in short supply, blah, 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 blah. This is the energy company saying all of this. We're at an interesting point where we have islands going under, we have coastal areas, and yet we're going to have our first trillionaire on the planet. We have more than enough money to solve, and we have more than enough science that goes back to this time. So I want to have the message, we can solve these problems. The longer we deny it, though, the more problems we're going to have. Again, the religious perspective, stated connected to social justice, but Martin Luther King said, we're now faced with the fact that tomorrow is today. We are confronted with the fierce urgency of now. In this unfolding conundrum of life and history, there is no such thing as being too late. Oh, there is such a thing, excuse me, as being too late. There is no time for apathy or complacency. This is a time for vigorous and positive action. So we have, and this is partly about social justice, because the rich will always find a way. Trillionaires are going to make out okay. So what have people been doing about this? So the first sort of call to the general public, outside of scientists and science educators who were well aware more than a decade before this, was this book called The End of Nature, which is a very pessimist-sounding thing. We can't destroy life on the world. We can destroy higher life. We can make a great place for cockroaches and bacteria. But as I guess it was Jurassic Park, the phrase that movie kept getting repeated, life finds a way. Life will survive. Whether humans will, and whether we'll survive in a way that we want to live, is another point. So this organization, 350.org, was found back in 2007. And at the time they were found, we were already well above the amounts of what they considered the acceptable amount of carbon, or carbon dioxide in there. And we've been adding ever since. So that's UN conferences. In '92, the UN decided to start focusing, and their first COP conference, of which we just had the 30th 2 weeks ago, was in 1995. The Paris Accord, we agreed that we were going to limit fossil fuels and limit the rise in temperature. We have blown past those objectives already. We're up to the 30th conference, and the first time ever, US didn't show up. Now, individual governors, some senators were there. The US had no formal government organization there. And in fact, our current president called the whole thing a con job. Again, this is not new. This is back to Joseph Priestley at the time of the American Revolution. This is not a new problem. And he had actually attacked and threatened countries that were trying to pull back on their use of fossil fuel. This is not good. This is not fiction. When I was in grade school in the early 60s, we actually had a thing where we got under desk. So we had images of nuclear explosions, and the idea was is you did this and got under a desk. Needless to say, that would not help you in a nuclear explosion, but it gave some people a feeling of control. Climate change doesn't have that same kind of, we got to do something now. But maybe it should. There's a neat video, which I had no intention to show tonight. If you YouTube Science Fair Nightmare, it's about 12 years old, and it's really funny and it's brilliant. The League of Conservation Voters put it out, so I'll leave that to you. So how do we know it's a fact? Because science is based on empirical evidence, which we have going back to Priestley, before the American Revolution, logical argument, and skeptical review. All that came together in that Paris Accord that said we got to internationally limit things. The data points, any individual storm, you can't say, oh, that's because of climate change. But when here locally we have the 100-year flood and the 500-year flood, just a couple years apart, you don't have to extrapolate much that we've got a problem. The Paris Agreement, which we have failed at, but on the good side, this is where we were going to be based on our projections. And due to the use of more e-cars and more energy efficiency, this is where we are. It's still beyond where the Paris Accord said we were going to be. And this year, last month, America didn't show up. Couple quick facts. Global warming and climate change, they're just a fact. It's not a theory, it is a fact. As much as we can say anything is a fact. It's also a fact that it's caused by humans. It's not some weird thing with solar cycles. It's not volcanic activity. It's humans that made the difference, again, between adding all these extra carbon dioxide since the time. That's human cause. There's no other cause for that. We also know it's messing up nature. Human beings are dying. We've had more people die in heat waves internationally in the last few years than in the last couple decades before that. On the positive side, we know there's win-win. So one win-win, I have a plug-in hybrid vehicle. In the 4 years that I've had it, the range pure electric is 40 to 50 miles, depending on temperature. It's 44 miles today. The batteries don't store as well as cold energy. To 50, almost all my driving is locally. If it all was local, my equivalent miles per gallon would be 99 miles per, or 100 miles per gallon. Given I take some trips like to the Smokies, in 4 years I've averaged 70 miles a gallon, and I'm spending about 85 cents for every 50 miles I go. So think if you had a car that got 50 miles a gallon, that's $3. I've spent under $1. That's a win-win. Drew has a pure electric. Again, this is nonsense. Just yesterday, it was reported that the higher mile per gallon standards that all of the industry, automobile industry had agreed to, were dropping it by like 20 miles a gallon. The president signed off on lowering, which simply means we're giving the whole e-industry to China. We've also cut rebates for solar. We're giving it to China. We're going to lose economically, and we need to change that. At the government level, in some states, Florida being a key one, and at the federal level, we can't use the words climate change. We can't use the word clean energy. We can't use the word green, emissions, and footprint. Those words now we're not allowed to use if you live and work in government agencies. Again, visually, we don't need words. That's forest fires, wildfires are happening all over the planet at a much higher rate. Hurricanes, droughts, all of that was predicted by our climate change models 20, 25 years ago. The concept of a carbon footprint is how much each of us individually and how much nations are contributing. Individually, if we took the whole planet, every person on the planet on average is producing about 4.7 tons. That's a metric ton, which is 2,200 pounds rather than 2,000s. So, but 4.7 tons of CO2. And you think, gosh, I can't be producing that much. Well, if you're an American, you're producing way more. So this is America first in the negative way. We have about 4% of the world's population in America. We're the third. China, India is, I think, right about the size of China now in population. We're the third next because we're big. But about 4% of the world's population is contributing 25% of the carbon dioxide. And we didn't show up at the international conference to solve this problem. And previously, we had the most scientific research going on this topic. We have National Science Foundation. We have the National Oceanographic, NOAA. We didn't show up. That's a problem. A couple quick religious perspectives. We're going to take it at an hour here. We'll make it. A lot of fuss was made about the past Pope Francis, but actually Pope John Paul II, all the way back to the World Day of Peace in 1990, was talking like a scientist. World peace is threatened by a lack of due respect for nature, by the plundering of natural resources, and by a progressive decline in the quality of life. The greenhouse effect has now reached, 1990, reached crisis proportions. The ecological crisis reveals the urgent moral need for a new solidarity. We have to stress the importance of giving attention to what the Earth and its atmosphere are telling us. There's a really neat compilation of all his writings called Following St. Francis. St. Francis, in the Christian circle, St. Francis of Assisi, is the patron saint of ecology. If you're interested in prayers, the prayer of St. Francis is the most Eastern Buddhist-like prayer in the Christian text, and it's brilliant, even if you're an atheist. It's just a brilliant idea. So Pope John Paul had a lot to say. Pope Francis made international news, though. He has two documents which I highly recommend reading. Lots of atheists and agnostics fell all over themselves. This is the first one on the care of our common home is a brilliant statement of Christian, or Catholic in this particular case, social justice. And Pope Francis was a chemist. So I don't think we have a mathematician pope now, so it's sort of fun. But Pope Francis was a chemist, and so it combines a chemist perspective on scientific understanding and a Christian. It is brilliant. He did a follow-up because not enough attention was paid, even though it got a lot of national press, with this second called Praise God, which is a little shorter and basically saying our responses have not been adequate. While the world in which we live is collapsing and may near the breaking point, our responses have not been adequate. So we don't need that. There is a national religious coalition that includes a whole bunch of Jewish organizations and Christian organizations. If you're interested, NRCC, they have some interesting resources. that bring together the concept of the science of ecological stewardship with economic. The countries that promote green energy are going to be the ones that make the most money. Fossil fuels are dead, whether we realize it or not. There's a limited amount of ground. It's getting more expensive. Solar energy now, again, we could have jobs all over the country. You can't export jobs to put a solar panel on your house or to insulate your house. So tons of jobs are available. So China's making out really well. America, not so much. Don't want to read this quote. Just back to Joseph Priestley. He founded the Unitarian Church. The Unitarian Universalist Association, the descendant of his church, has a wonderful statement about global warming and climate change. So if you look up Unitarian Universalist, that whole document is up there. There's a couple American groups, Interfaith Power and Light, a religious response to global warming. It's a neat organization. Faith for America is another one. They're a little more edgy. They cover all kinds of liberal topics, but do include climate change. OK, last 10 minutes, and I think we'll be at an hour. What can we personally do? So number one, we can support and actively participate in citizen action. And there's all kinds of neat groups here. I'm going to focus in a moment just on one, the Sierra Club. But these are all really good organizations that have been around for a long time, very grounded in science. The three that are listed in red are the ones that have a religious connection. Otherwise, the rest of these are agnostic, science-focused organizations. Almost all of them are not-for-profits. A few like Sierra Club, because of their lobbying, is not a not-for-profit, but does really neat work. Including, they've just in the last couple of months put out a series of online training, which just the other day, I knew about them, but just the other day I watched the four that they have out. The initial one, and then September, October, November. And their webinars that are online about what individually people can do, particularly if you're on social media, to make sure that more good news and accurate science news goes out. That's out there. Little story on the side, everybody, somebody, anybody, and nobody. And it ended up that everybody blamed somebody when nobody did what anybody could have done. So we each can do things, and we'll hit those real quick. Real easy on listservs. You get these kind of things all the time that send messages directly to your Congress people that we cannot deny science. In New York State, we have NIPERG. All of these are just within the last month. I get these every day. I belong to a lot of these organizations. So, and they make it really easy to write your Congress people. They need to know. New York State, right now, NICED, the New York State Education Department, between now and January 19th, this is right now, they have proposed to the Board of Regents that we add climate education to elementary, middle, and high school. And there's an opportunity to comment on that. My belief, education is an inoculation, if you will, like a vaccine against mis and disinformation. Separate book on the side, The World Becomes What We Teach. When we stopped, when we shifted from Carter to Reagan and we decided there is no energy crisis, there is no environmental crisis, largely our country's effort at the national and in most cases at the state level to educate people about how the world actually works that we knew at the time of the American Revolution. This is not new stuff. The basic ideas we knew then, we stopped doing. So most of my career has been in a time when education as a whole has not taught the basic facts of how Spaceship Earth works. The operating manual that was written in 1968, we've ignored that. That's a problem. Solutions work together. If you're in the school world, all these disciplines interrelate, and actually they interrelate with at least a portion of what people associate with religion values. There's a huge body of research, nothing directly connected to religion, called Values in Action. If you even look at Wikipedia, that research on values date back to the Greek philosophers. It's brilliant, and it's secular. And among other things, it teaches people that the world is connected and that we're connected to each other. So Spaceship Earth. The good news is green energies are becoming very, very popular, particularly worldwide. We just are putting there's a school that I'm on the board for that built a Catholic school in Kenya, and we're adding solar energy. There, they don't even get regular energy from fossil fuel because they have intermediate energy. We equip them all with computers, but if their energy is intermittent and they need energy to pump water, they're on the equator. So it's a total no-brainer. For like $4,000, we're going to take them off the grid. That's today's technology, nothing new and fancy. What can you do? Cars. Either use them less by telecommuting or ride sharing, or across that grid between high efficiency gas. My 2 cars back, I had a standard Honda Civic. Around town, it regularly got 39, 40 miles a gallon. That's a 2012. That is above the new standards that Trump just lowered our EPA standards to. That was a 2012 vehicle that did better, standard gas. I already mentioned my plug-in hybrid. Public transit is a good idea. Home energy. LEDs save you a fortune in money and tons of CO2 being produced, and they last forever. I have one LED, well, actually a compact fluorescent bulb that lasted 30 years in my house, and LEDs are way better. Reducing hot water with low flow fixtures, you get more force and use less heat. We shifted gas stoves, used to be the sort of ideal. It turns out they pollute your house. E-induction stoves are way, way more efficient, and they boil water in like seconds. You have a pot of water, it starts boiling in seconds. So there's all kinds of stuff. Home insulation, as simple as using bubble wrap. Adhere to windows, really easy. Put a little water on them and adhere. If the windows you're just using for light, and they're not seen from a distance, even without getting windows. So lots of things we can do in our homes. Eating. Overall, red meat is not good for you from a health perspective. And it turns out back in 1971, when I was in high school, a book came out called Diet for a Small Planet. I read it in '74, and all this information was known then. And what this is showing here is how much greenhouse gases different foods. Nuts are really good for you, except for peanuts, which are not nuts, they're legumes. Otherwise, grains, eggs, poultry meat, fish, pork, milk, cheese, all of those things for a given amount of energy produce way less carbon dioxide. Eating locally, grow some of your own vegetables. Don't waste food. There's a huge amount of food wasted, which is really producing pollution. Choices you buy less, buy stuff that lasts, buy stuff that's recyclable. In 1959, there was a book called The Waste Makers, where a social scientist wrote that we're going to cover the world with plastic. And we're making things that don't last. And that's going to be a problem. That's where we are. Reduce, reuse, recycle, the old 3 Rs. The modern version of that is rethink your choices, refuse single-use items, reduce consumption, reuse everything, refurbish old stuff, repair before you replace, repurpose, and recycle. Not as easy to remember as the 3 Rs, but the pollution that industry produces, they produce for us. So many people, oh, that's industry doing that. Industry doesn't produce stuff to pollute. They produce stuff that we buy. So better choices. The Bible has, if you Google money in the Bible has truckloads of warnings about it. Command those who are rich in this present world not to be arrogant. I'll just pick a couple. That seems appropriate. To do good, to be rich in good deeds, and be generous and willing to share. Do not store up yourself treasures on earth. No man can serve 2 masters. You cannot serve both God and money. So there's all kinds of biblical stuff that says walk more softly and care more about other people. 2 last ones. Our truth-telling president, President Abraham Lincoln, was just a fascinating, brilliant man. I could give a whole talk, 3-hour talk on Lincoln. He's so cool. In his second inaugural address before he was assassinated, he said, "The dogmas of the quiet past are inadequate to the stormy present. The occasion is this occasion, a civil war, is piled high with difficulty, and we must rise with the occasion. As our case is new, so we must think anew and act anew." We got to be honest. We got to be honest about our own individual contributions to the problem. We have to be honest and demand honesty from our politicians that we elect. And then the last message from the Bible, Deuteronomy. I've set before you life and death, blessing and curse. Therefore choose life that both you and your descendants may live. That is a message of consilience between science and religion. We need to be informed, scientifically informed, faithful stewards of Spaceship Earth. So that is the whole message. Very fast. I'm open for any questions if you have. Apologize for the speed, but and again, any of those slides will be available online that you can grab.
Well, yeah, we do have a question from the live stream. Mike asks, with the current U.S. administration, can conscionable states, California, New York, et cetera, work with international groups to continue our fight against climate change until the U.S. responds correctly?
Yeah, Governor Newsom from California was at this conference, as were, of course, Al Gore, our former vice president, who's been very much in this, and some other senators. So individual states, and again, if you're interested, California has an economy. It's one of the biggest in the world. When you count nations, California economy is up in the top 10, or maybe the top 6 or something. So absolutely. So states and local environments, Broome County doesn't have to wait for our president. There's things we can do in Broome County. Yes?
All right. Any other questions here locally? All right. Well, Tom, thank you once again for
Thank you
an
for your
outstanding, well-researched and so again, next week, next 2 weeks, we have the Star of Bethlehem movie, which actually talks about the astronomy behind what did the wise men see, and so you can sort of make your own decision on that. For those of you that are here, today for if you haven't already been in to see our telescopes, I'd be happy to give you a tour of that. Otherwise, we'll look forward to having you back up here again and watch for the deer on the way home. So, all right. Yeah. All right. Thanks again.